Relational databases ruled the information technology industry for almost 40 years, but last few years have seen changes in the way IT is being used and viewed. Standalone applications have been replaced with web-based applications, dedicated servers with multiple distributed servers, and dedicated storage with network storage. The main objective of today's presentation is to explore various cloud bases, advantages and disadvantages of using cloud databases. Cloud computing is a practice of using a network of remote servers hosted on the internet rather than a local server or a personal computer to store, manage, and process data. Cloud computing has become a reality due to its lesser cost, scalability, and pay as you go model. Cloud computing has brought a paradigm shift not only in technology landscape but also in the database landscape. With more usage of cloud computing, demand for provisioning of databases services has raised. The intense drive of any business to lower operational expenses and IT complexities has fueled a new breed of technologies known as cloud computing database. A cloud computing database is one which runs on a cloud computing platform.
Based on structure, cloud databases are categorized as relational and non-relational. Relational databases such as SQL rely on data that is highly consistent in its format, like banking transactions and telephone directory. Non-relational databases, sometimes called NoSQL, do not employ a table model. Instead, they store the content regardless of its structure as a single document. This technology is well suited for unstructured data such as social media content, photos, and videos. There are two primary methods to run a database in a cloud. One, virtual machine image, and second, database as a service. Cloud platforms allow users to purchase virtual machine instances for a limited time, and one can run a database on such virtual machines. Users can either upload their own machine image with a database installed on it or use ready-made machine images that already include an optimized installation of database. For example, Oracle provides a ready-made machine image with an installation of Oracle database.
With a database as a service model, application owners do not have to install and maintain the database themselves. Instead, the database service provider takes responsibility for installing and maintaining the database, and application owners are charged according to their usage of service.
Here is an example of cloud services database. AWS has a variety of cloud-based database services including both relational and non-relational databases. Amazon's relational database runs either MySQL, Oracle, or SQL Server instances. On the NoSQL side, Amazon SimpleDB is a schemaless database meant for smaller workloads. Amazon's DynamoDB is a solid-state drive SSD-backed database that automatically replicates workloads across at least 3 availability zones.
Here are some advantages of using cloud databases. Ensure optimum database performance, access, protection, compliance, and availability. Scalability. Cloud services typically allow for an on-demand scalability for peak times and sustained periods. Cloud computing lowers technology costs by significantly reducing the need for IT experts and staff, and by eliminating purchase of hardware equipment and software licenses. Additionally, many services are month to month without long-term contracts. Empowerment. Cloud solutions are typically a web-based interface for users. They can be accessed by employees, customers, and partners no matter where they are. In addition to all of the business benefits, cloud computing is all about virtualization and shared resources that provide more services for the amount of energy expanded when compared to in-house single-tenant solutions.
Here are some of the risks involved in using cloud databases. Limited control. Unlike a data center which is run by an in-house IT department, the cloud is off-premise system in which users outsource their data needs to a third-party provider. The bigger picture, however, is that users are trusting their data for someone else to look after. Since the cloud infrastructure is entirely owned, managed, and monitored by a service provider, it transfers minimum control over to the customer. The customer can only control and manage the applications and not the backend infrastructure itself. Cyber attacks. Although cloud service providers implement the best security standards and industry certifications, storing data and important files on an external service provider always opens up a risk. The ease in procuring and accessing cloud services can also give nefarious users the ability to scan, identify, and exploit loopholes within the system. For instance, in a multi-tenant cloud architecture where multiple users are hosted on the same server, a hacker might try to break into the data of other users hosted and stored on the same server. However, such exploits and loopholes are not likely to surface, and the likelihood of a compromise is not great. Once an employee gains or gives access to your cloud, everything from customer data to confidential information and intellectual property are up for grabs. The cloud makes this problem 10 times worse since the administrative access to the cloud management platform, either by an employee or an attacker posing as an employee, enables access to copy and steal any virtual machine undetected, as well as potentially destroy the entire cloud environment in a matter of minutes. Lack of support. Imagine being unable to access your cloud before a big meeting, or worse, being in the middle of a cyber attack that has taken down your entire bread and butter, your website. While some cloud providers have excellent customer support, others could leave you in cold. The most frustrating things when it comes when something goes wrong is not being able to speak directly with an engineer. Legal liability. Risks associated with the cloud are not limited to security breaches. They also include its aftermath, such as lawsuits filed by or against you.
To have a better understanding, here is a case study about the ransomware attack on MongoDB. Early on Jan 9, 2017, about 28,000 MongoDB servers had been compromised. The total amount of data held hostage was as high as 93 terabytes. The amount of potential victims in an attack like this is substantial. Here is a screenshot of the deleted database and the ransom note left in its place by the attackers. Ransom demanded were in quantities of bitcoins ranging in value from $200 to $1,000.
To conclude, information security has always been finding a balance between ease of access and the sharing of information versus completely lockdown security. The more you have of one, the less you have of the other. Thank you for being patient listeners to our presentation.